All right, so we are going to work on lesson 411 today. So we're going to work with addition and subtraction of decimals with a hundredths grid. So you're going to shade grids to represent and solve decimal addition and subtraction problems, understand the place value system, and perform operations with multi-digit whole numbers and with decimals to the hundredths. First, let's do some mental math and warm up here. So we have a little riddle, and it says write the numbers on your slate or a piece of paper at home. There are many correct answers. So let's see. I have a 7 in the tens place. So let's see. I know I got tens, and that means I have to have ones. And a 5 in the tens place. So I know I got a decimal here. And so tenths place, I have to put a 5. So I could put any number. I could put anything as long as I have a 7 in the tens and a 5 in the tens. Okay. The key is pay attention to that THS. That means it goes to the right of the decimal. It is a decimal, right? So let's look at this one. I have a 3 in the tens place. Ooh, they mixed it up on me. So I automatically know I have a decimal. So I'm going to put my decimal and put a 3 in the tens place and a 9 in the tens place. So again, the 9, again, you can put any digit in the ones. But the tens place should have a 3 and the 10 should have a 9. So again, more practice here. Okay, so you see hundreds and then you see hundredths. Pay close attention. The hundredths is a decimal, right? Okay, and let's look here. I see hundredths. They switched it up. Now, hundreds is in the hundreds place. Hundredths is to the right of the decimal, right? After the tenths place. Same thing here. Let's see what they did. If I scan through, I see thousands. And it's so important that you pay attention to that, right? And here they switched it up on you again. They said hundredths. And the other one is worth 100 times as much. So 100 times as much means times 10 to the second power, right? So you're moving 2 places to the left when you do that, okay? All right, so something that you might see come up for vocabulary math is called an add-in. Any one of a set of numbers that are added. For example, 5 plus 3 plus 1 equals 9. The add-ins are 5, 3, and 1. So the add-ins are basically just numbers in an addition problem that you're adding together. So let's see, we have a hundredths grid here, and how much is shaded in blue? So if I circle that, let's see, I know that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know this is 10, and that would make 20, right? But it's not 20, just 20, it's 20 hundredths because it's on the hundredths grid. How much is shaded in red here? Almost looks more like orange. Let's see, I know 1 row, 2 rows, 3 rows, 4 rows. There's 40 hundredths. And then let's see, 41, 42, 43, 44, 45, 46, 47. So 47 hundredths are shaded in red. How much is shaded in all? Well, I could add those together, or I could just count 1, 2, 3, 4, 5, 6 rows. That'd be 60. And then we know this is 7, so it'd be 67 hundredths, right? And so I could write an addition problem for that. I could say 20 hundredths plus 47 hundredths. And this is something you see on Evaluate. I think it's usually a subtraction problem, right? And so who wants to explain the answers in the math message? So we already looked at that and kind of explained there. So decimals are often used in real world situations that require knowing how to add and subtract them, especially money, or if you play baseball or basketball, statistics and things like that. You may have to do some adding and subtracting, especially with banking and money and things like that. So today you'll use grids to help you solve decimal addition and subtraction problems. So you're going to solve decimal addition problems using a red and blue colored pencil, shading the hundredths grid. Use red for the first add-in and blue for the second. If you don't have a red and a blue, you can change those colors out and just keep track of what it is you're using. Okay? So you obviously don't have the Math Masters page at home, but we could look at this a couple different ways. I could just line them up and add them up, even though if you don't have the grid, which we'll look at in a minute. And if you want to do it this way, you always just bring your decimal straight down. You add them up. And so on my grid, I should have 8 rows of 10 shaded in and one color, and then 7 squares colored in another. So you can see a couple examples here. Let me erase this so you can see it better. 87 hundredths, right? So you could, sorry, lost my spot here. You can see it got 87 hundredths. So they decided to separate them, and here they had the 1, 2, 3, right? And then 33 hundredths, and then the 54 hundredths here. And here they just decided to interlock them. So either way would work for that. Now, strategy number one, you could have shaded 33 squares for 33 hundredths, then started a new column and shaded 54 squares for 54 hundredths. There are 87 squares shaded in all, so the sum is 87 hundredths or 87 hundredths as a decimal. Make sure you don't write it just as 87 because that would be incorrect. Second strategy is you could shade 3 columns and 3 more small squares for 33 hundredths. Then I shaded 5 columns for 54 hundredths. I still needed to shade 4 more small squares for 54 hundredths, so I shaded them in the partially empty column I had for 33 hundredths. There are 8 full columns plus 7 more squares shaded. That is 87 hundredths in all. Okay, same thing here. I could line these up if I don't have a grid and just add them. But I could also look at this and know that I need to shade in 6 rows of 10 and then 5 more squares. Here I need to shade in 2 rows of 10 for 20 and then 8 more squares, right? But I could also, again, add it here without a grid, and I get 93 hundredths. Okay, and you can see there they were able to interlock those. They fit together pretty good, and that's how they shaded those. Not a lot of options for that one as far as how you could shade it. But how many columns do you shade for the tenths? Let's see. How many squares did I have in all to shade for the hundredths? Okay, so you think about the tenths. I had 1, 2, 3, 4, 5, 6, and then this full row, 7, 8. I had 8 tenths or 80 hundredths that I shaded in. And then for the hundredths, right, those would be the individual squares here. I have 1, 2, 3, 4, 5, 6, 7, 8. So 8 hundredths there. Okay, again, you want to solve this one. Let's see. Excuse me. Could I say I have 7 rows of tenths, 4 rows of tenths, right? And then 6 hundredths and 5 hundredths. And I can line them up, add them up, see what I get. In this case, I'm going to actually go over one whole grid, right? I have one whole grid and 21 hundredths. So you actually had to spill it into a whole nother grid. So you would have needed 2 to color there. Right, so I shade the tenths first. I need to shade 7 columns for the 7 tenths and 76 hundredths, and 4 columns for the 4 tenths and 45 hundredths. That was 11 columns in all, so I filled up one grid and started in the second grid. Then I shaded 6 squares for the 6 hundredths and 76 hundredths and 5 for the 5 hundredths. So you can see how they did it there. If you want to keep all the colors the same and then spill over, you can do that as well. All right, so you don't have the math masters. But if we look here at this example, and this is one you will see on Evaluate, not this exact problem, but subtraction on the grid, right? And so I could look at this and I have 64 hundredths. And I might want to go ahead and add a 0 just to make that 30 hundredths. It's easier, at least for me to understand. So let's say I have 1, 2, 3, 4, 5, 6. And then I have 64. And then I need to take away 30, right? So that's one whole row. It's 10, 20, 30. And then I could count the remaining sections to see what I'm left with. Also, I could just simply line them up, subtract them, and that also I could confirm my answer that way, right? Bring my decimal straight down, and 34 hundredths is what I should be left with. And if I look here, let's see, 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So exactly, I have 34 hundredths left. Okay, so how does the grid show 64 hundredths? Well, I can see here, if I look, it has 1, 2, 3, 4, 5, 6, right? So that's 60, and 61, 62, 63, 64. So how does the grid reveal 3 tenths? Okay, subtracting what we know 3 tenths on the hundredths grid can also be written as 30 hundredths. Right, so I have 10, 20, 30 that I marked off. So how's shading a grid to subtract decimals different from shading to add decimals? When I shade to add, I'm filling up more of my grid, where when I'm shading to subtract, I only fill in the first number, right? First add in there. and then I'm marking some of those off. So it's less shading, right? And more marking off there. Okay, so you could solve each of these problems here. I don't have the Math Masters for you, but you could solve these by simply lining them up. So you always want to line up the decimal, not the numbers, okay? So in this case, I would just have to add in a 0 and then subtract. And then remember, 9 can't come out of 0, you got to borrow. So you could line them up and subtract each one. So try that for some practice. Okay, and then if you look here, they did 7/10, or we could change it to 70/100 to make it easier to shade. They did 1, 2, 3, 4, 5, 6, 7, right? And then they subtracted 39/100. So then I could take away the 39/100 there, right? So 10, 20, 30, and then I take away 9, right? 1, 2, 3, go all the way up to here, right? And that remaining amount would be what I'm left with. And they marked it a little bit different than me, but you can see how they did that, right? And then for 52/100, subtract 14/100, right? Shade in 52/100, and then you could mark out 14/100. So I know one row is 10, and there's 12, and there's 14. So they could mark it different ways, but then you can see your remaining amount here is 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38/100. Okay, so you're going to complete Math Journal page 144. So go ahead and pause the video and complete that now. Okay, so hopefully you had a chance to try that. And again, if you don't have red and blue, that's fine. You can use any color. So you want to shade in the first one. And first thing I notice here is it's 100th grid, but this is out of 10. So I'm going to go ahead and change that to 60/100 and then shade it in, right? And then 22/100. All right, so you should have completed those already, so now you should be checking your answers. You should look something like that. You should have 2 different colors there, so again, it doesn't matter what the colors are. And then for subtraction there, remember you want to shade in the first add in there. So let's see, so 10, 20, 30, 40, and you want to do a better job shading than me. 41, 42, 43, 44. We go all the way up to 47 here. And then it tells me to subtract 20/100. So 10, 20, right? Then I'm left with a group of 10, a group of 10, and 7. So I should get 27/100 left. So you can try the next one here. Again, you want to shade in 74/100, then subtract, then mark off 36/100 of the 74/100. Okay, so you should already completed that. Make sure you do that. You can see their shading's a little bit better than mine, but it matches up pretty close. Okay, and then choose one of the problems above. Clearly explain how you solve that. All right. And then in your math journal, you're practicing plotting points there. On the next part, it says you can use fraction circle pieces, or you can just solve on 2. Remember, you must have a common denominator. Okay, and number 3, you're making an estimate and then solve. Don't forget to estimate. Remember, working with multiples of 10 or 100 is easier for your estimate to do mental math on that, right? And number 4, round to the nearest tenth. So remember, that's the first digit to the right of decimal. That's the one you're focused on, and you look in the hundredths, and the hundredths place will tell the tenths what to do. 5 above, you round up. 4 and below, you go down. And then number 5, explain the order of the numbers in order paired, why it's important. Okay, so that is the end of our lesson.